Hello, and welcome back to the stream. Let's get started from where we left. I was talking that I will write test for the handle failure. So let's get started with that. So I'll write the test. The thing is, handle failure requires external dependency. So we have to mock them. So the external dependency handle failure requires a queue and a job, which comes from job store. So we have to mock a queue and a job store. And also it depends on DLQ, as you can see here. So we also need to mock DLQ. Before writing the test, let me write the mock functions. What I will do is I will create a mock store first. I want to get done with these tests as soon as possible so that I can work on real features. But it is what it is. Tests are also important. So let's write those. I'll have a save function. Now let me get through my understanding why I'm doing so. The handle failure currently interacts with the our job store in two ways. One via update status and one via saving the job. So I will mock those two functions. How I will mock those is like it will be a fun. As you remember, um, our uh, job store uh, job store introduces some interface like where it is. Here are the interfaces: save, update status, delete. So I'll use those to leverage my test writing. So let me just paste this. So it will be a fun that takes a context, and yep, this is all we do. I, I will just define them here. I will not, sorry, this should, I need to import this star job dot job. Okay. So I will just define them here. I will mock them inside the function. So one is save func and other is update func, which will be for updating. So the function will be like, let me copy this one, Control C, Control V, and this will be update. Sorry, it would be found. Now status is job.status. Okay. Now I have mocked those, but I need this to satisfy our interface of the store. So I'll just write some small functions that M on our mock store has a save function. Save. Let me just copy this from here. Control C, Control V, and I'll define them here. Like what it does is it will return m dot save func, with the current context and the job. That's all we need, and it will be job. That's all we need to do here. Next thing is get. We need to satisfy those as well. Okay, this is our get. Let me just copy them once and just write a func and just copy this once. Control C, following, and Control V here, and Control V here too. Now I have all the functions. I just need to satisfy them. Job.status, job.status. Now our interface has been satisfied. One thing I need to define them here. So the get function, what it will do is it will return us a nil and a nil. Okay. Next is it will return us um, m dot update option. And last one, it will return us a nil. And that's all we need. And it needs a context and ID, the status. I think that's all we need to do. Yep. For the store walking, let me just walking job store functionality. Okay. Next thing we need to mock is our queue. So let me create a mock queue. Mocking queue functionality. Type mock queue will be a struct which will have let me check which functions are needed in our store. Sorry, in our retry package. One function I can see is q.name. Yep, a q.name is needed. Anything else? Do we dq or nq? We nq, so we need nq. So two functions I need is nq-func and func. And next function I need is a name func. So I will expose these two like func. I'll copy this from Q. Where are my Q? We got two implementation of NQ, DQ. I'll copy this here. I'll paste it here. And from here, I'll take this away. And it will be like one. One. That will be this. And the next thing we need to do is name function. That will be one. That will not take anything and will return out a string. Let me write the initials for every one of these, which is q star mock q. I'll copy this around and paste it here, here, and here. So that's all we need from here. Now let's define this. The nq function, what it will do is it will return the reference to our m.nq. So return m or what we defined here q.nq function, which will be taking a context and a job. That's all we need. DQ returns us return nil comma nil. Length returns us 0 0, and it will return us q dot name form, right? Then with the mocking of our queue, next thing we need to mock is our DLQ. So in the DLQ, the only function we need is save function from the DLQ. Let me go to this code. Here we are saving the job into our DLQ. So that's the only thing we need. So let me write the implementation. So first type mock DLQ to the struct, which will have a save function that will, let's copy the implementation of DLQ interface. And Let's take this out of here, paste it here, context, expected this to be this. Save func will be a func. Alright, this is done. Um, so here we will have to create a func that will be dq star no dlq. That's all we need. So we are creating methods of our dlq. Let me just do this part. And that's all we need. And let me format this first. Then I will write the implementation. The save function will return a call to our save dq dot save func that will take a context and a job, which is j there. All right, and it will return as nil and nil. We are not using these because we are returning nil because we are not going to use these. In the later stages, if I ever use these inside this package, I have to change the working. So mocking of all of the stores are all of the fronts are done. Uh, Mocking the queue functionality. Let me write here mocking the queue functionality. Done. Okay, now we can write the test. So first test we need to write before writing the test. Let me pass a context, which will be context dot background. Okay, so I'll use this context as the context for whole test. So first test we will write is if if we have a retry count and if we have a retry counts left, it should retry and return success, something like that. So let's write the implementation. I want to do it fast because I don't want to write more tests. Writing test is not fun at all. Retry success. Okay, so it will give us a function which will be firstly what we'll do is we'll create a job, mock job, which will be job dot job type. It will have a ID. Let's call it job one, and it will have a retry count. The only things we are concerning with retry count and max retries as let's say 3, and let's add a delay of 100 millisecond. Time dot millisecond. So we have a job here. This is a mock job. So let's write implementation upon this. So what happens when a job goes to our retry engine? Firstly, its status get updated to no. Firstly, it will be, let's see the implementation. So firstly, what happens is if it should retry, then the status updates. Yes, this was the part I was using. It gets the status updated to status pending, and then we enqueue it back to the queue. And do we do anything else? No. For the happy path, this is our implementation. We need to test. So it will firstly update the status and it will enqueue. So I need to let's have two booleans. Store updated is equal to false. Currently the store has been not updated, and enqueued. Oh, sorry. enqueued is equal to false. It means the job has been not enqueued yet. Now I will write the functionality of our mock store and mock DLQ. First, let's write the functionality of mock store. The mock store will be %, mock store. It will have a function, meaning update function, which will be fun. And what we will do is, how we'll write it? If ID, so that we can check if ID equals to job1 and status, what we call it, status equals to job status, job dot status pending. Then we'll call the store as updated. Okay. If the job status is set to pending, then we will call the store as updated. And it will return nil, which is it returns an error, so it will return no error after doing this. So this is our update functionality. It will just set the store updated to true. All right. Next thing we need to do is mock the queue. Mock queue equals to %, mock queue. Okay, we will have to need a enqueue function. The enqueue function will be a function like this, and it will do is it will again check if job ID equals to 1, and that we just cut this out from here, and it will set the enqueued to true. And here will be job.id, and it will return nil. Right, so mock queue has one clip, and the other name function we also need here, which will be a function that will return. Let's return an name. Let's return test queue, and that's all we need. Next thing, do we need to use DLQ here? No, we don't need to use DLQ as we discussed earlier. So let's create a new engine. Retry engine, new retry engine. It will have a store, which will be our mock store. Okay, it will have a store, which will be our mock store. Delay, let's set the max delay to 10 minutes. And DLQ. We don't have DLQ need here, so I will pass nil along the way. And next thing we need to do is I'll call the engine.handle failure, which is our testing environment and testing function. So what it does is it takes a context, a queue, and a job. So let me pass the context as it is a queue, which will be our not queue, and a job. The job will be J, which is defined here. Okay. Yep, this is all we need. I need to use this operator. So everything is done here. The function has been called. It internally calls this and this. So now we'll check the behavior. I will have different behavior. First, the retry count will be increased. Currently, the retry count was 0. After handle retry is called, the retry count will be j.retry. If j.retry count is not equals to 1, that means there was an error. So j.error f expected retry count to be 1. Retry count to be 1 dot what percent b, which is our j dot retry account. That's really next thing. If the store is not updated, we expected the store to be updated, so we will say t dot error t dot error. You don't need to pass along anything. Job status was not updated, something like that. Next, if not enqueued, then we will write job was not re-enqueued, which is job was not re-enqueued. Enqueued. Nice. Next thing, we'll check if job status is changed. There can be an issue, something like a store got updated, but the job status was not set to pending. So we will check if status is not equals to j dot job dot status pending. Then we will say expected status pending. I'll pass along t dot error expected status pending got percent v, sorry, percent v, which is a percent s here, but which is j dot status, and that's all we need. The type of status, so yeah, it will be converted easily. And the next and last thing we need to do is one thing which is done here is whenever the handle failure is called, we set delay to next delay and j dot run after to the time added after that. So it means j dot run after will be set in future. So we have to check if j dot run after is set in future or not. If j dot run after dot before, if it is before time dot now, that means there was some issue. T dot error f run after was not set in future. This is the error. Oh my god, yeah, okay. And this is the happy path. I think this should work. Let me run it. It runs okay. The next thing we need to do from the handle failure, we need some other paths. Like when job needs to be moved to DLQ, it means job failed. Job fails when retry count reaches max retries. So let me just write the implementation. So it will have a test case, they don't run, move to DLQ. Okay, fine. Testing function, which will have a job. We'll copy the job from here and paste it here and have retry count equals to max retries. Let's change the job ID to job 2. Next thing we need to do is what happens here is we save the job into the store, update the status to failed, and also save the job into DLQ. So that's all we need to check. So the first thing I will check is store save. Store updated. Now I will check store save equals to false. Okay. Next, next thing, store updated, because store is also store status is also updated. Job status is also updated in store. And last, DLQ saved. It means the job was saved in DLQ or not. False. So let's write the implementation for mock store and mock DLQ. The three functions I need to write are mock store. I can copy mock store implementation from above and just do this, and I will do mock store ID will be job ID 2. The update function will be, and here job dot status dead. Store update equals true, and that's all we need from here. One more thing we need before this is our save function. Okay, it will be a function, and this is how we will implement this. And let's implement the function. What the function will do is it will check the job ID. If job dot ID, ID equals to job 2, then we will do is we will say store saved equals to true and return null. All right, the implementation for mock store is done. Next, we need to write the implementation for mock DL. Mock DLQ. Not this one, mock DLQ. Which will be like mock DLQ. It will have a save function, which will just simply do the same thing as we do with the store. So let me just write the implementation. Pause, please. Sorry. One will be like this copied, this pasted. I will pass along job dot what is the issue? J.id. Here in the J.id means if J.id equals to job 2, I will say DLQ saved equals to 2 and return here. That's we need for our mock DLQ. One thing we need from mock queue is check the name, because whenever handle failure is called, it checks the name. So let me write the implementation here. I will copy this one and just use it there, removing the empty function, everything completed, and that's all we need. Okay, let's create the engine and the new engine handler. Handle failure function. Okay, the prerequisites are done. Now we will test it. What we need to test is if the store does not get saved, updated. So I will copy this. I'll paste it 2 times. So updated store, save, and store updated. Job state was not saved in store, like this. The job status was not updated in this. And the next thing we need to do is we need to check DLQ save job status. Job was not saved in DSP. Job was not saved in DL. Nice. Next thing we need to check is the status flag being set to dead. We'll call this one out. Job.status dead. State expected status dead. This. And next and last thing we need to check is one thing, as you remember, whenever retry count exceeds, we set the error, which is here, max retries exceeded. Okay, so we will check if j dot error is not equals to max retry exceeded. So I will copy this one, is not equals to, so j dot error is not equals to max retry exceeded. Then we will have t dot error f expected error uh, max retries exceeded dot percent q with j dot f. So percent q, what it does is it will add quotations alongside the string. All right, the test for this is done. Mock DLQ is not being used. It's not being used. I need to pass the mock DLQ there. And now I think the test is done. Let's run the test. It's passing. Let's move on to the next test. Next test we need to check is what if context gets cancelled? So retry engine firstly checks if context get cancelled, it passes along j dot error equals to this, and it will also print this statement out. So we will check if j dot error is not set to this, then we will say it is not good, something like that. So let me write the functionality t dot run context cancelled. How is it? Like, press success context cancelled. Okay, so what I will do is I'll write a function that will take a cancel context. We'll have a cancel context pass along it. So ctx comma our cancel function, it should be equals to context dot with cancel parent context to the context, and that's all we need for this element. Yeah. So next thing we'll do is we'll call the cancel function. This will make sure the context gets cancelled, and yep, that's all we need. We'll create a job, doesn't job dot job with the ID only, which is job 3. We created this job to check j dot error. That's all we are doing. So we'll create an engine window. Let me paste it from the old thingy. So I'll pass along nil, and mock q will be nil, because we are only checking the context. Here, central context should be sent with cancel context, and that's all we need to check. Now we'll check if j dot error is not equals to our error, as we said, was this. Let me just write this down. If j dot error is not equal to this, we will have t dot error f expected error to be expected context error, that is better, dot percent q, that is j dot error. And let's test this out too. This should pass easily. The next thing we will do is we will test the functionality of one last thing, which is inside this here. Here you can see If should be write functionality if update status failed, if NQ fails, should we write that? Should we write it not? Well, update status and that is already tested, I think. I think this much is enough. Or should I? Hmm, let's wrap it up. This is all we need. These are the tests we need for our retry engine. Let's give it a go. I've set up my CI/CD pipeline, CI pipeline. So new tests will make the system stronger. Let's test this out. So test. Slash done. Here's our retry. Let's go with retry. It was okay. Yeah, that is great. So our tests are passing. Next thing we need to do is write test for our pool, the worker pool. Worker pool will also need some, mocking. I have also written some small tests for the worker pool. A small test which was checking if add queue starts the worker pool before the start is called. That's one thing I tested. Now I need to test the working. So um, let's get started with it. Firstly, let's check what the worker pool demands from other places, like from store and other places. So the worker pool uses a store, a registry, a retry engine. I don't think I need to mock the retry engine. Retry engine can work fine. First, I need to mock the retry engine. Yeah, I need to change the handle failure function. So I need to mock this, and anything else I need to mock. Uh, yep, I need to mock this with the job handler. So registry, I need to mock. I need to mock these. I need to mock three things, and it also depend on queue. So I need to mock the queue. That's all we need to mock. So let's get started the mocking. For the mock store, let's copy the mock store from here. I'll change the functionality as needed. First, let's keep it close together. Okay, let's mock them here. Let's keep these and these different from each other. Okay, so we will have a mock store. The mock store here will need, as I remember, update function and a delete function. The delete function for our when jobs succeed. As you may remember, here we update the status in the store. Also, after job is completed, we delete the job which sets the TTL in the real app, but here we will mock it. So real project. So let's mock them. Save function is not needed. So what I will do is I'll return nil here. I'll consolidate it into a one line, and I'll define a delete function here. Delete one, which will be function that will be like this. Control C, Control V, and that's how we need. And here it will return a call to delete form with the context is passed along and the ID is passed along. So I'll make it two line now so we can understand which functions are being mocked here and which are not. Okay, mocking job store, mocking job store. So next thing we need to mock is our registry. So let's mock registry. So what the registry does is it is the registry of handler function. So we need to have a map there. Handlers is a map of type string, and it gives us a handler dot handler. For reference, let me tell you where the handler is written. Here it is written. It returns a new whenever we call a new registry. This is how it happens. So registry has a handler, just like this. We have walked this here, and it will have a get job function, just like here, this one. So let's call that. So it will be like this. Okay, I think this is what we need. And here, let's mock this func, which will be a R mock registry, which will be get, and the get function, what will it will do is to check h. Okay, because we are simply querying, so I don't need to pass it on the function signature handlers m dot handlers. Sorry, here we will be using r dot handlers. M was from this, that's why I got here confused here. So r dot handlers, what it takes is uh, r dot handlers dot r dot handlers with the job type we are going to set here, job type. So it will give us a handler and an outer statement will return h dollar. Okay, and that's what we need to do from mocking the registry. Next thing we need to mock is our retry engine. So the retry engine will be like type mock retry engine. Okay, let's mock the retry engine. It will be a struct. Writing test is so boring. Handle failure. Oh, so you remember this just gives us a handle failure. So let me copy this from here. This is how it is defined. Let's copy this, let's paste it here. And let's paste it together. Sorry. Control C. And it will be a fun. That fun. That does this. That takes this and nothing else. So what we will do is we'll have one over RH star. We'll try engine, which will be like need to import that, and it will return us or do about re dot handle failure function with calling like text q and of job j. What is the issue there? What is the issue? How do you use this? re dot handler function. No value used as value. Yep, we don't need to return this. We just need to call this because it's a void function. Yep. Next, we need to implement. Let me just write the arguments. Mopping. How did I do that? Mopping. Handle registry. Registry. Mopping the handler function. Mopping handler function. Sorry, mopping retry engine. What am I doing? So I will mock the retry engine here. Next thing I will do is I will create a mock handler um, that will be a uh, handler function implementation. Mocking handler. So let's write the implementation that will be type mock handler which will instruct will be like this. Yes. So what it will have is it will have a handle function that will be like our function and function. What it will do is it will take the form of our handler function, which is like this. So let me paste it here. And the next thing I need to do is write a function on our mock handler mh start mock handler. We need to write a function here. The function will be, we paste it, handler, handle. I remember it was handle or handler. We need to check. It was handle. Yep. We need to write handle here. And what it will do is it will return a call to our mh dot handle with the context pass along like this, with job pass along like this. So our handler has been mocked. Last thing we need to mock is our queue. So the things I need to mock in our queue is we need to check first whatever will do with the queue. The queue, firstly, it checks the queue, it checks queue.name, one function we need to mock. Next thing it does is queue snapshot here. It doesn't call the queue anymore. So wait for work doesn't call run worker dequeue. So we need to dequeue the jobs. And anything more we need? Do we need to enqueue the jobs too? Obvious, just delete and process the job. And do we need to enqueue the jobs? That is a question. I don't think so. We need to enqueue the job here. We can leave enqueue job. I can check once more. Instead, I can check via enqueue. We don't call enqueue anymore. Enqueue. We call dequeue. We call name. Else we have checked. Do we call length? Q.length. Not this length. We need Q.length. So we need to mock two functions. One is dequeue function and other is our what do we call it? The function to um, uh, pass along the name. Let's check it out, man. What it does. Oh, sorry. I think I need to also have a NQ functionality for the idea I have in my mind. Let me write this. Mocking um, Q for control. We could have used a normal queue, but we need control, so I will name it a manual queue, which will be a start, which will have name, string, and jobs, which will be a channel. So I'll be writing jobs into a channel so I can check jobs with you. So let's write the functionalities. Func will be MQ star manual queue, which will be like MQ. We need to copy the. I think I have it in my clipboard. Do I have it? Do I have it? Do I have it? I think I have it. Yep, I have it here. So the function I first need to check is this. This is the function I need to check. Context. It's double entry. And that's all you need. Function NQ. What it will do is it will MQ dot job. It will pass along the job into the channel, and it will return. And then this is for demonstration. I don't think NQ will be used, but for demonstration, what I am doing is this is what I'm doing. Let's go with PQ. So let's copy this down. All right. Sorry. Alt, alt, Control V. This is what we did. This is here. Let's call this here. And let's write the implementation for DQ. So DQ will run a select statement. It will have a case where J has a job. Thank you, jobs. So it will return us the job. And next, if we have a default case, it will block until return. It will not block right. It will return nil, and it will return errors dot new empty queue, something like that. And for our length function, I'll return I'm just writing the implementation for this one. Return the length of mq.job. Lastly, the new function will return mq.name. So this is our queue for controlling the whole flow. Because worker works on the queue, and that is where the main processing happens. So we need a manual control over there. So the first test I will write is for testing worker pool processing. Worker pool processing. I will test the worker pool processing status. So pass along a context and a cancel function, which will be context dot with timeout. I'll pass along with timeout so that the test does not get you know what we call it. The test does not get stuck, and the time, let's say, I'll give test 2 seconds. I have a cancel function and a context. I'll defer the cancel function and let's write the subcases. First subcases process job successful. I'll have a test function like this. So what I will do is I will check all the status the job goes through. I will check if the job gets deleted or not. I will and what other thing I need to do here? I don't think anything is not need to be done here. So let's write the test. So for checking the status, the job status, after I will change, I will write status change as a slice of job.status. So it is a slice of job.status. I'll have a boolean that will dictate if the job get deleted or not. Because after successful execution, the job gets deleted. So I will also have a wait group WG, which will be type of sync dot wait group. Okay, and I will add the wait group value to 1. So what I will do is um, I will add the wait group value to 1. I need to call wait group dot wait going to call. Let's go with this one. Add second to which come to the console here. Read if the contribution happy. Okay. So store. Let's create a store. Which will be our mock store. And let's have some update function. The update function will do is it will append the status change equals to append with the new status. Done, and it will be done. Well, next thing we need is delete function. It will simply set deleted to true, and here we will set the wait group dot done, and we will return email. Okay. Next thing we need to mock is our handler. Mock handler. Or a handler, whatever we want to call it, but let's call it mock handler. And this does not look good like store. Let's call it mock store. Sorry, I lost mock store. Okay, let's create a mock handler, which will be like mock handler, mock handler. Currently as a handle function. So what can we write in our handle function? Let's return one. one, it will return nil. So whenever jobs call this function, it will return nil, and the calling has processing has been done. That's all we need to do. And mark the registry here. It will be m small m. Mark the registry, which will be m%. Mark registry. So we need to write the handler goes to math handler with a handler name, let's say test, and the handler be our mock handler. Well, there's issue mock handler is defined. Mock handler. I just defined it above there. Oh, I never called this operator. Here I also didn't call this special issue arrows. So now I have passed this. Now what we'll do is, now the real processing will happen. We'll spawn a new virtual tool, which will be new virtual tool, um, text store, which will be a mock store, registry, mock registry, a retry engine. We don't need retry engine for this one. Num workers, let's say num workers to 1. And for the sake of it, I need to pass along the try engine. So let me pass along the mock try engine, because if you remember, I have also already set the functionality for our retry engine, which is like this. All right, I think this is done. Then we will add a queue. We'll create a queue first. Manual queue. So the manual queue will be having name, which is just okay. Next, it will be having jobs, which is make. I'll make channel jobs job, and we will have a buffer to 1. All right, because we are going to test this only one job and all that. Tool dot add queue. We'll call the add queue functionality, which is queue, and tool dot start. We'll start the processing here, and defer tool dot stop. All right. Next thing we need to do is create a job, and default job job. Let's have ID. Call it job 1, and type job type will be our test type, same as our handler, so that the job will pass there. Next we'll do is queue dot jobs. I'll add the job into this one, which is like this. Now you can understand why I wrote the enqueue, and now I think enqueue is not needed. We will return nil here regardless, but no harm in letting it be like this. So no issues. We'll let it remain like this. So this is what enqueue does. So I'm enqueuing a job. I'll wg dot wait. I'll wait for the process to be finished, and after that, if not deleted, firstly we will check if not deleted, then we will have g.error, which will be like job was not deleted after successful processing. Um, let's have a d.error. Next thing we need to do is transition from running to done. The job gets first to running, then it gets to done. So for that, let's do it. Wait for a second. Okay. What we can do is let's set two booleans. Found running set to false and the found uh, done set to false. Okay. Let me write a small comment here. Expecting transition from running to done like this. So we will loop around the our status changes. So it will be range status change. So each status will be given here if s equals to dot status running then you will simply say found running equals to true. And if wait for a second guys, I have to attend a call. Let's call this s equals to job dot status dot. Sorry for the interruption there. So found done will be set to true. All right, and I've set all this. Now we will check if not found running or not found done. If either of those is not set, we will call error f, which will be missing status transition. Missing status transition. Dot percent q status change. Status changes, and we will pass an ampersand to be there. So we can simply define status change, and this is done. Oh, there is a lot of testing needs to be done yet, but let's stop at this today. It is passing. We'll continue the testing tomorrow, and I think by the end of this week we will have fully what do we call it, fully testable project, something like that. Also I will shift from writing tests for every function to uh, something like writing tests for important things only. Okay, so let's meet tomorrow. Thanks for watching.